Hello, everyone. My name is Farooq, and I'm from Team 8. And my teammate is Kaundinya. And today we'll be presenting our project titled Spotify Top Hits Exploring Sound of Popular Music. Our dataset includes 2000 Spotify tracks between 1998 and 2020, and each song comes with 18 variables covering artist and genre information, popularity scores, release year, along with a range of audio features such as valence, loudness, energy, danceability, and tempo. Talking about our research focus, our analysis centers around three main questions. Number one, we explored whether we could uncover meaningful mood-based clusters of songs that go beyond traditional genre labels. And yes, our results showed that clustering songs by mood reveal clearer patterns and trends than genre alone, which could help music recommender systems perform better. Number two, we examined how different music genre families vary in popularity, musical traits, and how these patterns have actually evolved over time. Overall, we found that music has become more expressive, rhythm driven through the years, with pop and hip hop rap leading in popularity, rock and dance staying the most energetic, and most genres becoming more explicit and emotionally nuanced. This really reflects how sound and culture have evolved together over the last 2 decades.
So, to begin our EDA, we begin by looking at what makes a song popular in measurable terms. So, our goal is to see whether audio features like energy, danceability, or tempo can actually explain why some songs gain traction over others. So, to do this analysis, firstly, we just began by looking at the distribution of song popularity and we calculated all kinds of correlation scores between audio features and popularity. We first checked if there is any linear correlation, and then we checked if there is any non-linear correlation to see if there is any clustering when we plotted a scatter plot between the popularity and each audio feature. We also did a bin analysis in each of these audio features to see if we go from a lower to a higher bin in a particular feature, would there be a drastic increase in the number of songs that are popular. We also then did a tier analysis where we created popularity tiers and see how many songs of each feature value are present in each tier. Finally, we've done a box plot where we displayed the full popularity distribution of each category within each feature. This is the smoking gun, where each and every single box plot showed nearly identical distribution across all feature categories. Individual and a sad song and a happy song both span the entire popularity range from 1 to 89. This told us that individual audio features are not meaningful drivers of song popularity. The small statistical differences that we found between 2 to 4 points are completely dwarfed by the variance within each category. When we look at the full distributions, they're nearly identical, regardless of feature values. This makes intuitive sense because song popularity is determined by factors outside the audio file itself, like artist fame, a viral moment, or cultural timing, and so on. The audio features themselves describe what a song sounds like, but they cannot capture why people listen to them in the first place. This is important information, especially in the age of AI, where people can try to generate music artificially and try to come up with some sort of an algorithm to generate a popular song. But this proves that there is no secret audio formula for creating a hit. So, after realizing that single features can't explain popularity, we shifted focus to how songs relate emotionally. Instead of predicting success, we wanted to see whether combinations of features naturally form mood clusters. Before we could create clusters by mood, we first needed to understand which features actually represent mood and whether they overlap or capture different emotional dimensions. So we chose these five: acousticness, danceability, energy, tempo, and valence. And they turned out to be largely independent, as you can see, which is exactly what we wanted. Valence showed mild relationships with energy and danceability. So each feature captures a unique mood dimension. With that confirmed, We plotted songs on a valence energy map, happiness on the x-axis and intensity on the y-axis. We divided the space into four mood zones: sad, melancholic, intense, aggressive, energetic, happy, and calm, content. And the pattern was quite clear. Most of the songs fall into the high energy half, as you can see, with very few songs in the calm and content zone. This showed that mood exists on a continuous spectrum, not in neat clusters. Still, to analyze mood further, we created six explicit mood categories using valence and energy thresholds. We then asked the key question: do moods cut across genres? By simplifying each song to its primary genre, we found the genres overlap heavily with multiple moods and vice versa. For example, pop songs spread across every mood type. Finally, we ran a coherence test comparing how tightly songs group by mood versus by genre. And as you can see, songs group by mood more tightly than by genre because they have a much smaller standard deviation. And a smaller standard deviation means that songs in that group are much more similar to others of that group. So, in conclusion, mood is a much stronger and more meaningful way to group music than genre, which is very important when you're trying to make recommendation algorithms in music apps like Spotify. And now Farooq will take over to explore how these musical characteristics have evolved over time.
So, when I began this analysis, I had only one main question. How do different music genre families differ in their popularity and musical characteristics, such as explicit content, and how have these traits changed or evolved over time? The goal was to uncover the distinctive musical profiles of each genre, understand how these traits have shifted historically, and determine whether explicitness plays a meaningful role in shaping popularity. Talking about some data preparation, which I did. At first, comparing genres was very tricky because many songs belong to multiple genres. To fix this, I separated multi-genre songs into individual entries and basically sorted them into broader genre families such as pop, rock, hip hop, rap, country, and electronic dance. This gave a clean foundation for comparing genres more meaningfully. Let's talk about genre composition. We can see that pop clearly dominates the dataset, representing the biggest share of songs, while other categories like jazz and classical are much smaller. About talking about popularity, we can see that rock is the highest in popularity, and pop and hip hop also stand out. They consistently achieve higher or high average popularity, showing their broad mainstream appeal. So let's talk about explicit content now. This plot compares each genre's explicitness rate with its average popularity. We can see that one genre family immediately stands out, the hip hop rap category. It had by far the highest proportion of explicit songs, while country, jazz, and classical were almost entirely clean. So it was surprising to know that genres with more explicit songs weren't less popular. In fact, they were the most popular. This shows that explicitness doesn't reduce mainstream appeal. Instead, in some genres, it's a defining trait that fans connect with. And this led me to question whether explicitness is associated with popularity for all genres. And to test this hypothesis, I ran a t-test comparing the popularity of explicit and clean songs within the rock and hip hop category. So in rock, we found out that explicit songs were significantly more popular than non-explicit ones. But for hip hop, we saw that explicitness made no real difference statistically. So we can say that the effect of explicit content depends on the genre's culture and what its listeners value. Let's just go over some time series analysis now. So yes, uh, energy over time. We can see that rock and dance electronic music maintained the highest energy levels, though all genres experienced a mild dip around the 2010s. Pop saw a late rebound, reflecting more and vibrant production styles, Valence declined nearly across all genres, showing that modern songs have become more emotional or introspective. Rock and R&B soul in particular showed a gradual shift towards lower tones and explicit content over time. We can see that explicitness increased sharply in hip hop rap, especially after 2010, while pop and R&B soul also became more open over time. And other genres like rock and dance music stayed relatively clean throughout.